In this video I will show you exactly what the visual logger is, how to use it in both Blueprint and C++, and why it might become one of your favorite debugging tools in Unreal Engine. So what exactly is the visual logger? Instead of just talking about what the visual logger is, let's see it in action. I'm going to play a quick round in the Unreal Engine 5.6 arena shooter template while I cover the basics. At its core, the visual logger is a powerful built-in tool that captures gameplay data over time and presents it in a timeline. Think of it like a time machine for your game logic. You can record events, locations, values, and then go through your play session to see exactly what happened, when it happened, and where it happened in the level. It's a huge step up from console logs or temporary debug shapes that disappear after some time or clutter your entire screen. And while playing around in the arena shooter template, I was already using the visual logger to track some key gameplay elements. For example, every time a weapon was picked up, I logged a simple message to the visual logger showing which weapon was picked up and who picked it up. Just clean textual log entries. I also used the visual logger to visualize the player's location while jumping. Each frame during the jump, I logged the character's position. This allows me to clearly see the full jump path afterward, frame by frame. But it gets even better. By connecting these individual points into a curve, I was able to draw a full arc of the jump, which makes analyzing the jump behavior incredibly easy. On top of that, I tracked the behavior of projectiles in the scene. I logged their movement direction over time and used arrows in the visual logger to represent this direction throughout their lifetime. On the left side of the visual logger, you also will find a detailed breakdown of various properties. These are fully customizable and let you easily track how specific values change over time. Pretty cool stuff, right? And the best part, I will walk you through exactly how to set all of this up in both Blueprint and C++. But already a heads up, some of the things can only be done in C++. But first, how do you actually open the visual logger? For that, navigate to the Tools tab in the top of the editor, go to Debug and then select Visual Logger. Here you get a nice handy tab that you can dock somewhere inside your editor. One of the first things you will notice in the visual logger is the timeline. And when you open it for the first time, it will be empty. If you hit play and move around in your game, you see that nothing actually is changing. That is because the visual logger is not actively recording yet. To start recording your session, just click the start button. From that point on, the visual logger will be capturing gameplay data you have defined, which you can also confirm with the message in the top right of your game viewport. And once you're done, hit stop to end the current session. On the left side of the timeline, you will see which actors are linked to the events in each row. Now, when you scroll through the timeline, you can see how things change in the scene, and also view the associated logs for each point in time. You can also use the arrow keys to step through frames one by one and zoom in or out by holding down Ctrl and using the mouse wheel. Visualizing the data can actually be done both while your game is running or not. And here's a nice bonus tip: you can save and reload visual logger sessions, which is perfect if you notice something interesting and want to revisit or share it later. At the top of the visual logger, you will also find a list of categories. These represent different systems that data has been recorded from during your session. Many of Unreal's built-in systems already make use of the visual logger, especially things like AI behavior. So you might discover useful insights here that don't show up in the regular output log. You can easily toggle each category on or off by clicking on them, helping you focus only on the data that matters to you. But now it is time to look at how we can put the visual logger to practical use in your projects to capture data that actually is relevant to your gameplay. First, let's talk about how to control the visual logger directly from C++ or Blueprints. We start with C++. If you want the visual logger to begin recording automatically when the round starts, you can enable it from within your game mode class. In our case, let's open up the shooter game mode and add the following line inside the begin play function. This line grabs the global visual logger instance and activates recording. However, there's one important thing to remember. The visual logger is only available in non-shipping builds. So to keep things safe, you should wrap any visual logger code inside an enable visual log if statement. This way, the code is excluded from packaged shipping builds, avoiding packaging issues later on. If you're working in Blueprint, you can start recording like this. Open the GM Shooter Blueprint and go to the Begin Play event. Add the Enable with Log Recording node and set Enable to True. You will notice this node is already marked as development only. So you don't need to worry about excluding it manually from shipping builds. Once that's set up, start your map that uses the shooter game mode and the visual logger will begin recording automatically. But you will notice that the visual logger continues to record even if we end the session. But what if we want to stop the recording in that case? Let's go back to C++. In your shooter game mode, override the endPlay function and call this. This makes sure that the visual logger stops recording when the game session ends. And in Blueprint, it's just as simple. Add the endPlay event to your game mode and then plug in another enable with log recording node, but this time set enable to false. With this setup, your visual logger starts and ends recording automatically. No extra clicks needed. Now that we have the visual logger up and running, let's start logging some custom messages. Beginning with something simple, printing a message whenever a weapon gets picked up. Let's again start with C++. Head over to the shooter pickup class and locate the code where the pickup logic is handled, which is inside the onOverlap function. And this is also where we will insert our visual log entry. To send a message to the visual logger, you can use this macro. Let's break it down. First, you have to provide a log owner. This is the object that the log entry is associated with. Next, you have to provide a log category. This helps organizing your logs. Each message will appear under its category in the visual logger. Next, you have to provide the verbosity. I covered this in other videos already, so check out the link in the description to read more about each verbosity level. And lastly, you have to provide the text, which is the actual message. To define your own log category, you can add this line to the top of your CPP file. This creates a custom log category, and since it's defined as static, it's only available within this file. If you want to learn more about defining log categories globally, check out this video. If you also want the message to show up in the regular output log alongside the visual logger, you can use this macro instead. Now, to avoid unnecessary work during runtime, you can check whether the visual logger is actually recording. This ensures your logging code only runs when the logger is actually recording without unnecessarily impacting your performance during normal play. You can also log text to the visual logger from within Blueprint. Open up the BP pickup blueprint and locate the onComponent begin overlap event. Here you have to add the with log text node. This node lets you send a message to the visual logger directly from Blueprint. Here you can also freely enter the category under which the log should appear. To also print the message to the output log, click the small arrow on the node and check the box Add to Message Log. One thing to note, Blueprint doesn't provide a built-in way to check if the visual logger is currently running. So, if needed, you can create a custom Blueprint accessible function in C++ that returns the logger state using fVisualLogger is recording. And you will notice, even though we are only logging text to the console, there's still a visual marker in the world. That is the default location indicator showing the position of the log owner for that event. So far, we have logged simple text messages, but there's another way to handle reoccurring events with visual logger events. Unlike normal text logs, events are reusable markers you can define once and trigger from multiple places in your code. You give each event a name and a description, and then you can reference the same event across different gameplay situations. Let's now use events in C++ to track when the player starts and stops falling. In your character class you have to override two functions: onMovementModeChanged and landed. Then at the top of your CPP file you can define the new visual log events using define vlog event. Each event needs a name, which in this case is falling start and falling end, a verbosity level, and lastly, a small description explaining the purpose of this event. Now, inside onMovementModeChanged, check if the player is falling and trigger the falling start event using UE vlog events. And in the landed function, trigger the falling end event like this. Now, when you play the game and jump around, you will see that the events falling start and falling end will both appear in the visual logger timeline. The great thing is, you can also add additional information to your events by using UE vlog event with data. So instead of creating two separate events for starting and ending a fall, we can also define a single event like falling event and use it in both situations. When the player starts falling, we pass in the text start, and when they land, we pass in end. This way, both logs are grouped under the same event category, but still carry distinct meanings. And if needed, you can attach even more custom data to provide deeper insights into what happened during that event. Sadly, visual logger events are not supported in blueprints, but you can still achieve something similar by using the withlog text node and using different log categories and/or text messages. And if you're finding this video helpful so far, consider hitting the subscribe button. There's more Unreal Engine content coming your way, and if you want to support the channel even more, becoming a member really helps me keep making these videos. So a huge thanks to my current supporters. But now back to the visual logger. Logging text is great, but the real power of the visual logger lies in visualizing gameplay data directly in your level. So let's do just that. As an example, let's visualize the player's location while falling. This way we can see the exact trajectory of the jump frame by frame. To do this, we can override the tick function in the first-person CPP character class. Inside tick, we'll check if the character is currently falling. If so, we log the current location using the UE vlog location macro. Let's quickly break that one down. The first few parameters you already know. First a log owner, then a log category, and then a verbosity. Next you have to provide a location, which is the word position to visualize, then a radius, which is the size of the debug sphere, a color, which is used for visualization, and you have to add a label for the point. This text that you enter here will also be displayed next to the point in the world. So, if you don't want any extra information to be displayed, you can just add an empty string here. This will draw a small colored sphere at the character's position for each frame they are falling. The same thing can be done in blueprints with the withlog location node. Simply open your character blueprint, use the event tick, add a check to see if the character is falling, and then call withlog location and plug in the character's position, a color of your choice, and a radius. Now, if you press play and start jumping around, you will notice that your visual logger timeline is now filled with many more entries while falling. Each one of those shows us the player's position at that point in time. As you go through the timeline, you can follow the jump arc precisely. And now we can see where the player started falling, how they moved mid-air, and where they landed. But now comes the fun part. We have visualized single points while falling, but what if we want to show the entire arc of the jump from takeoff to landing? By default, the visual logger doesn't offer a built-in way to draw such arcs. But that doesn't mean we can get creative and build our own solution. To create a custom arc, we will manually track the player's movement through the air. Here's how. Create a T-array F vector in your character class to store each location while falling. Inside tick, if the character is falling, append the current location to that array. When the fall begins, make sure to clear the array so we start fresh. And finally, when the player lands, loop through all stored points and use UE vlog segment to draw connecting lines between them. This draws a line between each pair of points in the array, essentially reconstructing the full path of the jump. I keep the label in this case empty because otherwise the text would appear multiple times next to each of the segments. The same technique works in blueprints too. Add an array of vector as a property in your character blueprint. On event tick, check if the character is falling. If yes, add the current location to the array. Now, on movement mode changed, when the player starts falling, clear the array. And lastly, when landed, loop through the array and use withlog segment to draw the lines. Now when you play the game, jump around and then go through the visual logger timeline, take a look at the last frame of the jump. You will see an arc of connected lines that perfectly map the jump path from launch to landing. This can be helpful when fine-tuning motion curves or comparing different air behaviors across characters. But the visual logger also supports a variety of built-in shapes that you can use to visualize data. For example, let's recreate the scenario where we want to visualize the movement direction of a projectile using an arrow. To do this in C++, open the shooter projectile class and override the tick function. Inside tick, first check whether the projectile has already hit something or not, because if it has, there's no need to visualize its movement behavior anymore. If the projectile is still flying, you can visualize its velocity using UE vlog arrow. Here, the first vector you have to provide is the starting location of the arrow, and the second point is where the arrowhead is located. The same thing can also be done in Blueprint using withlog arrow. This gives an easy way to draw arrows in the visual logger without writing any code in C++. Now, when we fire a few projectiles in the game, you will see entries for the projectiles will appear in the visual logger timeline. Each one showing the projectile's movement direction, visualized with an arrow. If you are curious about what other shapes are available, check out the visual logger header file. There you will find a wide range of shapes, more than enough for most use cases. In Blueprint, simply type withlog into the node search bar to see all the available visual logger nodes for blueprints and their shape options. Earlier, I showed you how the visual logger can also be used to display a list of information on the left side to depict the current state of your actors. These are called snapshots, and they are automatically created whenever an actor interacts with the visual logger system. To add custom snapshot data for your own actor, you need to do the following in C++. First, make sure your class implements the interface iVisualLogger debug snapshot interface. This interface defines a single function that you need to override. Grab debug snapshot. Make sure to also wrap the declaration and implementation of this function in an if enable visual log block, so that you don't have to worry about packaging later. This grab debug snapshot function is called automatically every time the actor interacts with the visual logger. Now, to add and organize your custom debug information, you can create new custom categories here. First, add a new empty category to the snapshot status array, and then get a reference to this new category through the index. And then give the category a name. Each category acts like a tab where you can store relevant values. For example, you might add a character's current location and velocity like this to the category. So, by adding the label of the data and then the data value itself. One important note, the value for the data has to be provided as a string. Once that's in place, play the game and open the visual logger. You will see that every visual logger entry for your player character now also includes the location and velocity at the different points in time. You can also create subcategories to organize it even further. You can define a new subcategory like this, add your values as before, and finally assign it as a child to your main category. Now, when you run the game again, you will see that the location and velocity are now grouped under the movement subcategory. When a snapshot is taken, you can also trigger normal text logs and shapes like this. However, unfortunately, snapshots are not supported in blueprints. So if you want to make use of this feature, you have to get your hands dirty in C++. Now let's look at one more powerful feature, redirecting visual logger output from one actor to another. Say you have added a log inside your weapons fire function. Right now, the weapon shows up as a separate entry in the visual logger. But what if you want this information to appear under the character and not the weapon? You can do this using a redirect. In C++, open the weapons begin play function and call redirect to vlog. Here you are telling the visual logger to associate the weapon's log output with its owning character. And for that, we can simply call getOwner in this example. After this, if you fire the weapon in game and check the visual logger, you will see that the fire event now appears under the character instead of the weapon. In Blueprint, this same behavior can be achieved using the redirect with log node. Just pass in the original source, which in most cases is self, and then the new target object. In C++, you can also implement additional snapshot functionality for the weapon. For example, we could now keep track of the current ammunition every time a snapshot is taken. The basic setup for the snapshot is like before. First, we have to inherit the interface and then implement the function grabDebugSnapshot. However, since we are already using a redirect to our character, we can simply search for the category we defined earlier, like this. If we get a valid index, we can create a new subcategory and add our ammunition value to it. Now, when we run the game, pick up a weapon and start shooting, you will see that the ammunition value is tracked correctly, listed under character info. And if we pick up another weapon, you will notice that it gets its own separate entry in the list with its own ammunition value. So you can see using snapshots offers a lot of great functionality to keep track of gameplay values in an organized way, making debugging them a lot easier. And that's it for today. You are now ready to start using the visual logger in your own Unreal Engine projects to debug and visualize gameplay data more effectively. And if you're working primarily in Blueprints but are thinking about checking out C++, be sure to check out this video next.